Good evening, everyone. So, welcome to this machine design revision classes. Okay, so we have the two session for this particular subject. So, if I will talk about the weightage of this subject, that will be around 4 to 6 marks. Okay, so this is the syllabus which will be mentioned in the GATE website. Okay, I hope you have gone through this particular syllabus. Now, what we will plan, so I have taken some of the good problems, okay, good conceptual problems. So we will try to learn the concept through the questions. Okay, so in these two classes, we will practice more questions so that you will be confident if any new questions is also coming in the gate, you can easily able to do it. Okay, so I have categorized this particular syllabus in this particular sequence, and I have given the important weightage for each and every topics based on the star mark. Okay, so if I will talk about, we will proceed in this particular format only. So the first one is theories of failure. That means you have to design any particular component. Okay, so there is a need of the theories of failure, and then there will be a failure strength and ascent diagram. Okay, against the dynamic loading, and then we will move to the brakes, clutches, and in case of joint also there will be three different types of joints: the riveted joint, bolted joint, and the welded joint. In case of bearing, so one important relation is there, the load and life relationship, and one more characteristics parameter, that is Sommerfeld number. Okay, and in the gear, so sometimes they are asking the question based on the strength of beam strength, we can say that, and the force analysis. And one marks question they can frame from the spring chapter. Okay, so this is the syllabus if we will talk about the machine design. Now, first of all, understood the theories of failure you already know. So you already attended the all the live classes. So we will try to practice more questions only. So in case of theories of failure, we have various theories. Okay. So for example, maximum principal stress theory, maximum principal strain theory, maximum shear stress theory, which is also known as a Guest and Trescas theory, total strain energy theory, and distortion energy. Out of these theories, mostly they are framing the question based on the Guest and Trescas, which is shear stress theory, and the second one will be the distortion energy theory. Okay, so based on that, I have taken one problem that is based on the Guest and Trescas theory. Okay, so in this question, what you have to calculate, you have to calculate the factor of safety. So first of all, what is factor of safety? What do you mean by factor of safety? Ultimate strength divided by design strength. Very good. So factor of safety. So meanwhile, while solving the questions, I will give you the important concept as well as important results which you will use for solving the problem. Factor of safety is nothing but the failure stress. Okay, the failure stress divided by allowable stress. Allowable stress, which is also known as a working stress. So I can also write the failure stress divided by working stress. So this failure stress will be different for different material. So if I will talk about the for ductile material, the factor of safety can be written as yield tensile strength divided by working stress. Similarly, for brittle material, it will be ultimate. Brittle material, this stress will be ultimate. So factor of safety is ultimate tensile strength divided by working stress, or we can say that it is a design stress, or we can say that it is a allowable stress. Okay, so different name we can use. What is the question? So they have given the state of stress. Either they can give in this particular format, that means sigma x, sigma y, tau xy, or otherwise they can represent in the form of this one. So the state of stress, this is sigma x, this will be sigma y. So I would suggest you everyone please mute yourself. So sigma y and this is tau xy. Fine. So sigma x, sigma y and tau xy, which is already given as a numerical value. So from there, first of all, you will calculate the principal stress. Okay. So now there will be a note point which I am discussing how to calculate the principal stress. Sigma 1 and sigma 2 can be calculated as sigma x plus sigma y by 2. This is from the state of stress, plus minus sigma x minus sigma y by 2 square tau square xy. So as you know that the state of stress which is already given in this question, that is 80 megapascal as the sigma x, sigma y is 20 megapascal, tau xy is 40 megapascal. Okay, so from here you will easily get the sigma 1 and sigma 2. Now, as per the Tresca's theory, so absolute maximum tau max you have to calculate. As per the Tresca's theory, that is nothing but absolute tau max should be less than equal to yield shear strength. So when this condition is satisfied, then we can say that our component is safe because we are designing the component. So what will be the important result? So sigma 1 minus sigma 2 by 2. Okay. So you have to take the absolute tau max, means the maximum value of sigma 1 minus sigma 2 by 2, sigma 1 by 2 and sigma 2 by 2. Okay. So here we are assuming sigma 3 is 0. So if it is 0, so sigma 1 by 2 and sigma 2 by 2. Now, what is the maximum value? Let us suppose sigma 1 minus sigma 2 by 2, you are getting as a maximum value. Now, as it is less than equal to, so you have to consider the factor of safety. Okay, so the yield strength, if you see, they have clearly mentioned the shear yield strength is 100. Okay, that means this is the maximum stress that material can withstand. But for design purpose, what we will consider? We will consider the factor of safety. So if I will divide n, then this is our working stress. If you see, the n value is nothing but the factor of safety n is nothing but the failure stress, which is the yield shear strength divided by the working strength. So working strength we have calculated here, yield shear strength divided by n. Now, once you have calculated the sigma 1 and sigma 2, you just check and then you will get the factor of safety. So for this particular Tresca's theory, the yield shear strength having a relation with yield tensile strength, which is nothing but the yield shear strength can be written as yield tensile strength by 2. So whenever they have mentioned the shear strength, then there is no problem. You can just equate these two. But if they have mentioned the strength of the material, so always consider that is yield tensile strength. Okay. Now you just read this question and try to solve. So sigma x, sigma y and tau xy, which is already given. So from there you will get the value of sigma 1 and sigma 2, and then you will move to the absolute tau max. And from there you will easily get the factor of safety. Anyone? Yes, very good. Navinita, your answer is correct. Option B is the correct answer. Yes. So now, so parallelly you have to solve with me. So sigma 1 and sigma 2 is nothing but sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau square xy. So as the sigma x is 80 and 20 and 40. So sigma x is 80, sigma y is 20 and tau xy is 40. Okay, so which is already given in the problem. So once you will solve, you will get the sigma 1 and sigma 2. This is nothing but 80 plus 20 divided by 2 plus minus 80 minus 20 divided by 2 whole square plus this is 40 square. So this is nothing but 50. So this is 50 plus minus 30 square plus 40 square, which you already know, which is nothing but 50 square only. Just 1 second. So which is nothing but 50. So now from here you will get the sigma 1 and sigma 2 is nothing but, so if you take this positive value, that will be corresponding to sigma 1, which is called as the major principal stress. Sigma 2 is basically is nothing but for minor principal stress. So can I write sigma 1 is 100 and sigma 2 value will be 0. So from here, if you calculate sigma 1 minus sigma 2, what is this? 100 divided by 2, okay, which is equal to, what is the yield strength they have mentioned? So now they have mentioned as a shear strength. So then there is no problem. So for example, okay, I'm talking about what are the possibility of the question they can frame. So suppose they have mentioned as a strength of the material, so always consider it is a yield tensile strength. And you know that yield shear strength can be written as half of the yield tensile strength. Okay, so now you can check here. So, but in this question, they have clearly mentioned this is 100. So, from here, you will get the factor of safety is 2. That means option B is the correct answer. Okay. So, from this particular question, first of all, you understood how to calculate the major principal and minor principal stresses. And then, once you know this value, now how you are calculating the unknown parameter as a factor of safety. So, if they have given the yield tensile strength, you just put the yield tensile strength by 2 here, and then again you can calculate the n value. Okay. Now, let's move to the next question. So I hope this question is clear to everyone. You can comment in the chat box. Now, this is the question was asked in again gate exam. The ratio of ultimate stress to the design stress. Just now I have discussed. It's really straightforward. So you know that the ultimate stress divided by design stress is nothing but the factor of safety, which I have already mentioned. You can check it here. So factor of safety is nothing but failure stress by allowable stress. Always remember this important formula, because if I am talking about the brittle material, then I will use ultimate. If I am talking about the ductile material, this stress will be yield tensile stress. Okay. So in this particular question, the correct answer is option D. Okay. Let's try to solve this problem. This is also the question based on maximum shear stress theory. Just to have a look. So sigma 1, sigma 2, sigma 3. Now they have given sigma 3 also. So I have told you, whenever you are calculating the absolute tau max, so what is the formula? The maximum value of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, and sigma 3 minus sigma 1 by 2. So in this particular problem, they have given the sigma 3. But in the previous problem, that is the biaxial state of stress, so sigma 3 is 0. Now, you will calculate this value, whatever the largest value is there, then you will equate with the failure stress divided by factor of safety. One more important thing, if you read this question carefully, in this particular problem, they have clearly mentioned, this is GATE 2017 question, tensile yield strength. Okay, so if they have mentioned yield strength, again I'm repeating, consider as a tensile. If they are specifically mentioning the tensile, that is better. But if they have mentioned shear strength, then you have to consider shear one. Yes. 2 is the correct answer. So as you know that maximum shear stress theory, which is nothing but absolute tau max, can be written as yield shear strength divided by n, and they have given the yield tensile strength, and you know the relation, yield tensile strength divided by 2n. Now the question is how to calculate the absolute tau max. You already know the absolute tau max can be written as larger value of or maximum value of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, and sigma 3 minus sigma 1 by 2. Okay, so all these values they have given. So if you put this value sigma 1 minus sigma 2, which is nothing but 60 minus 5, which is 55 divided by 2, and similarly for this value, then you will get the largest value, which is nothing but 50 megapascal. Okay, so this is the maximum value you got. Now what you will do, you will equate with the design stress. What is the design stress? The 50 can be equating with the yield tensile strength divided by 2n. So yield tensile strength is also given 200. So from here, the n value you will get as 200 by 100. The answer is 2. Answer is 2. So the factor of safety you are getting as a 2. That means option B is the correct answer. Yes, Navi. Absolute Tom X is 50 megapascal. So let's move to the next question. So this question based on von Mises stress. So von Mises theories of failure. So let me recap what will be the von Mises stress formula. So as you know that you every time calculating the design stress, which is the working stress. So in this case, again, you will calculate the working stress, which will be equal to yield tensile strength divided by factor of safety. So in theories of failure, most of the time they are asking what is the factor of safety. The yield tensile strength, which is already given. Now see, they have clearly mentioned yield strength. I have told you when they have mentioned yield strength, so always consider it the yield tensile strength until unless if they will not specifically mention as shear yield strength. Okay. Now the working stress in this particular case is nothing but sigma 1 square plus sigma 2 square minus sigma 1 and sigma 2. Okay. So if you read this question carefully, a specimen of steel has the yield strength, the specimen yield strength of 700 megapascal, the specimen is subjected to a state of plane stress whose stress value is sigma 1 and sigma 2 both are same. The factor of safety according to von Mises theory. Okay, so that you have to calculate. Try to solve and tell me what answer you are getting. Good. 1.4 is the correct answer. So you will calculate the working stress, which is you will get as 500 only because this sigma 1 is 500 square plus 500 square, and this sigma 1 and sigma 2 both are same, which is nothing but 500 into 500, which is 500 square. So this will be cancelled out. So you will get working stress is 500. Now what will be the factor of safety here? Factor of safety you can calculate. The yield strength is given as 700 and this will be 500. So what is this value? 1.4. This is also a gate problem. What will be the correct answer? 1.4. Correct. So I hope everyone is ready with your calculator. So try to solve in the class itself. Now read this question carefully. So I have talked about they can give you the sigma 1, sigma 2 or sigma x, sigma y. They can mention. The other format is they can give you the state of stress sigma x, this is sigma y, let us suppose this is tau xy, or otherwise they can give you in the form of stress tensor. So this is called as a stress tensor. So these are nothing but sigma x, tau xy and tau xz. Okay. So this is sigma x, all these diagonal element are the normal stresses and these are nothing but the shear stresses. Okay, so again you have to use von Mises yield criteria. So you have to calculate what will be the yield shear strength. Now, first of all, what you will do, as you know that this is sigma x, this is sigma y. So if I will write here, sigma x is 10 megapascal. So I hope the unit they have mentioned in megapascal only. Yes. Okay. So sigma y is nothing but 20 megapascal. And now if you see here, this is sigma 3. Why? Because all the shear stress component are 0. So if the shear stress is 0, that normal stress can be considered as a principal stress. Okay. So sigma 3 value they have clearly mentioned. Sigma 3 is nothing but minus of 10. So if you want to represent the stress tensor in 3D, so this is basically the representation. Those who don't know, you can follow this stress matrix. Sigma x, tau xy, tau xz. This will be tau yx, sigma y and sigma z, tau yz, tau zx and tau zy. Okay. So these all values are given as 0. That means this is a principal stress. Now from sigma x, sigma y and this tau xy, you will calculate the sigma 1 and sigma 2. And you know that how to calculate sigma 1 and sigma 2. So tau xy, which is given as 5. So sigma 1 and sigma 2, once you will solve, anyone, what will be this value, principal stress? You already know the formula for sigma 1 and sigma 2. What is that? Sigma x plus sigma y by 2 plus minus square root of sigma x minus sigma y by 2 plus tau square xy. Okay. Now from here you will get the value of sigma x, sigma 1 and sigma 2. What is the value of sigma 1 and sigma 2? So once you will solve the sigma 1, you will get around 22.07 and sigma 2 value is 7.93. Okay. Now this is basically the von Mises criteria only. Yes, 22.07, 7.9. Now you know that von Mises criteria is for a triaxial state of stress, sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square is equal to 2 times of yield tensile strength. Okay, so this is the generalized formula for von Mises stress. If you put the y sigma 3 value is 0, so sigma 3 is 0, so what you will get? Sigma 1 square plus sigma 2 square. Okay, again from here you will get as sigma 1 square plus sigma 2 square minus 2 sigma 1 sigma 2. Okay, now sigma 1 square and sigma 1 square will become 2. Similarly for sigma 2, so you will take this 2 common, it will be cancelled out. Again you will get the same result, sigma 1 square sigma 2 square minus sigma 1 sigma 2, which we have considered in this case. Okay, so this is for the 3D state of stress and this is for 2D state of stress. Now sigma 1, sigma 2, sigma 3, which you already know. So from here you can easily get the value of yield tensile strength. Okay, so first you will get the yield tensile strength, but what they are asking, yield shear strength. So as you know that in case of Tresca theory, the yield shear strength can be written as yield tensile strength divided by 2. Okay, this is for Tresca theory. This is for the Tresca theory. Now for von Mises, this value, the yield shear strength can be written as yield tensile strength divided by root 3. Okay, so once you got the yield tensile strength value, now for yield shear strength, you can use this relation yield tensile strength by root 3. Okay, this is for Tresca theory and this is for the von Mises. So anyone got the final answer? 16.07. Very good. So once you will solve, you will get 16.07. So yield tensile strength you will get around 27.82. Now from here, yield shear strength is yield tensile strength divided by root 3. So once you will solve, you will get 16.07, which is option B. Okay. So if any question is coming from either from the Tresca theory or von Mises, you were able to solve it. Because in von Mises stress theory, we have to use sigma 1 and sigma 2. Okay. So in this case, the state of stress is given. So in this one, the shear stress is 0. So this is sigma 3. So based on this state of stress, what you have done here, they have clearly mentioned sigma 1 and sigma 2. But in this case, they have given the state of stress. Then you have to calculate sigma 1 and sigma 2 value first. Got it, Naveen? Okay, fine. So now I am taking one more problem, which is little bit advanced, very good problem, which was asked in GATE 2016. Okay, so this is the mixed problem of Tresca as well as von Mises. Okay, so just have a look, read this question and try to calculate the unknown parameter. So what you have to calculate, you have to find the relation between the factor of safety which you are getting from Tresca and the factor of safety which you are getting from von Mises. So they have mentioned the factor of safety is for Tresca is small n subscript as a t, and for this one is von Mises v. Okay, so the state of stress they have given sigma 1, sigma 2, sigma 3 they have mentioned. Okay, I can frame one more question. So let us suppose instead of giving this sigma 1 and sigma 2 and sigma 3, I will give you as a this particular state of stress, which is nothing but sigma x, sigma y, sigma y. So first of all, what you will do, you will calculate sigma 1 and sigma 2, and then you will proceed for the remaining part. But they don't want to test your numerical ability, they want to test your conceptual understanding. Okay, that's why they have given directly the sigma 1 and sigma 2. Now you already know for the Tresca theory as well as for von Mises, just calculate the factor of safety and then find the relation. Okay, so try to now if you see, this is mentioned as a yield strength. So it is basically a shear strength or tensile. First you tell me, if they have mentioned the yield strength, this is a shear strength or a tensile strength? Very good. So always remember whenever they have mentioned yield strength, so that is nothing but tensile only. Okay. Now what you will do, first of all, you will calculate the maximum value of shear stress, which is nothing but the larger or maximum of sigma 1 minus sigma 2 by 2. Okay. So these all are in mod. Sigma 1 minus sigma 2 by 2, and then sigma 2 minus sigma 3 by 2, sigma 3 minus sigma 1 by 2. Okay, so this is the maximum shear stress for the which theory, that is for maximum shear stress theory, that is Guest and Tresca, yeah, Tresca theory. Okay, now the maximum shear stress theory you already know, that is nothing but yield shear strength divided by n. Now I am using the same notation, so n for Tresca. So as you know that the yield shear strength can be written as yield tensile strength divided by 2n. Now what is your main aim? To calculate the absolute T.I.M.E, which is the design stress. So sigma 1 minus sigma 2, if you do 100 minus 100 is 0, and this 100 minus 0 divided by 2 is 50. This is again 50. Okay, that means you are getting this value is 50. What about this sigma yt? They have mentioned as a 200. So 200 divided by 2. So from here you will get the n value as 2, small n t, which is Tresca. So you got the value as a 2. Yes, many of you got the correct answer. So let me check for maximum distortion energy theory, which is also known as a von Mises. So as you know that, what is the important relation? Sigma 1 minus sigma 2, just now I have discussed. Sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square is equal to 2 times of the yield tensile strength. Now they have mentioned as a factor of safety, so you have to consider factor of safety here. Fine. So if you see the previous relation also we have used. Now from here you have to calculate the value of n. So sigma 1 sigma 2. So again if you see sigma 3 is 0. So can I write this relation sigma 1 square plus sigma 2 square minus sigma 1 sigma 2, okay, which is equal to yield tensile strength divided by factor of safety. You can take the square root. Okay, that means it is biaxial state of stress. Why? Because sigma 3 is 0. So once you will calculate, so let me use the same notation, which is NV. So yield tensile strength is already given, which is 200. Sigma 1 sigma 2 is given. So once you will calculate, you will get as a value. That means option C is the correct. Many of you got the option C, that is correct. Okay, I hope these both the theories are clear to everyone. Yes or no? Let's move to the next question. One more advanced problem. Okay, so these problem will help you to approach if any new questions is also coming. So if you read this question, so now every time they are giving the sigma x and sigma y tau xy value. Now instead of tau x, they have given you the torque value. So you know that whenever the torque is acting on the shaft, how to calculate the shear stress value. Okay, so if you read this question, a circular shaft of diameter d, which is fixed at one end, subjected to an axial force which is P, and a torque T on the other end. The torque T is nothing but PD by this torque T, which is given as PD by 8. The tensile yield strength, which is given as sigma y. Okay, according to Tresca yield criteria. So now you have to calculate according to this particular criteria what is the value of P. P means the applied load. How you will solve this problem? Okay, so that means one particular shaft is there whose one end is fixed, and another end, if you see, so this is your circular shaft. One end is fixed, another end is subjected to a load of P, and there is one more load which is acting as a torque. So now that means this is basically a combined state of stress. So in which the axial load is also there, shear stress also there because of the torque. So you know that the axial stress, which is nothing but sigma x. Suppose if I am taking this is the x axis, this is y, and this will be z. So sigma x can be written as P divided by A. So axial load, what is the area of shaft? This is diameter d. So can I say the pi by 4 d square? So sigma x you already calculated. Now you have to calculate the value of the shear stress. So the shear stress is nothing but 16T by pi d cube, which is the maximum shear stress only. So whenever any particular shaft or a rod which is subjected to a torque, so as you know that the maximum shear stress is 16 T by pi d cube. How this result came? T by J into R. J is basically the polar moment of inertia, which is nothing but pi by 32 d to the power of 4, and this R can be written as d by 2. So once you will solve, you will get 16 T by pi d cube. Okay, so this is the maximum shear stress. So they have not given the shear stress, they have given the torque. Now you are using this relation. Fine. So you already know the sigma x and the tau value. So can you calculate sigma 1 and 2? Sigma 1 and 2 is nothing but sigma x plus sigma y by 2 plus minus sigma x minus sigma y by 2 whole square plus tau square. So in this particular problem, sigma y value will be, anyone can you comment in the chat box, what is the sigma y? Sigma y is nothing but the stress in the y direction. What is the sigma y? Very good, 0 only, because the one stress is in the x direction. There is no stress which is acting in the upward direction. So sigma y is 0. So can I say this is sigma x by 2 plus minus sigma x by 2 whole square, and the maximum shear stress you already know, which is nothing but 16 T by pi d cube. So for this T value, that's why they have given in the format of P and D. So once you will keep here, you will get the sigma 1 and sigma 2. Sigma 1 and sigma 2. So sigma x value is 4p by pi d square. Okay. So if you divide with 2, so what you will get? So can I say the 2p by pi d square plus minus again the same value 2p by pi d square, and this is nothing but 16 into t value is p into d by 8 divided by pi d cube square. Okay. So if you take the 2p by pi d square common, so you will get the sigma 1 and sigma 2. Sigma 1 and sigma 2. Okay. So let me write in the next slide. So sigma 1 comma 2. So again I am writing the same 2p by pi d square plus minus square root of 2p by pi d square. So 2p by pi into d square. So if you solve this, you will get the same. So this is nothing but 2p by dd will cancel out. Again, you are getting this value. So if you take this 2p by pi d square common, what you will get? So can I say this value is nothing but 1 plus minus root 2. So if you take the positive, you will get the sigma 1. If you take the negative, you will get the sigma 2. And in case of maximum shear stress theory, which is Guest and Tresca's theory, what is the value of maximum shear stress? Sigma 1 minus sigma 2 by 2. Okay, that means if you calculate this value and you will equate with the yield tensile strength divided by, let me rewrite again here. So absolute maximum shear stress is sigma 1 minus sigma 2 by 2. Now which you will equate with yield shear strength divided by factor of safety. So they have not mentioned anything about the factor of safety, so you can consider as a 1. What is the yield shear strength? So I can write in terms of yield tensile strength, because they have clearly mentioned the yield tensile strength is sigma y. So can I say this is nothing but sigma y by 2. Okay. So now you have to calculate the sigma 1 minus sigma 2. Sigma 1 minus sigma 2. So which you already know, if you subtract, you will get this value. So which is nothing but, so from here sigma 1 you can write 2p by pi d square 1 plus root 2. Similarly, sigma 2 you can write as 2p by pi d square 1 minus root 2. Fine. So if you subtract this sigma 1 minus sigma 2, if you subtract this, what will happen? So this will be cancelled out. So only this factor will be there. That means you will get this value p pi d square divided by 4 root 2 into yield tensile strength. Okay. So once you will subtract this, you will get pi d square, or we can say that this will be cancel out only. Okay, so 2p by pi d square root 2, and this will be plus root 2. So 2 root 2, which is already 2 is here, that means 4 root 2 p by pi d square. Now if you equate these two, you will get this relation. Okay, so now you can check here. So the p value is equal to what will be the correct answer? Option A. Very good question. Okay, so in this particular problem, if you see, the only thing is they have not given any kind of shear stresses. They have given you the torques. From there you have calculated the maximum shear stress, and then you have proceeded with the same Guest and Tresca theory. Sigma y is 0 only. That's why I have taken 0, no, Naveen? So sigma y is 0, which is nothing but 0 only. Got it? So only axial stress is there and shear stress, which is torsional shear stress, which is tau. Okay, you just have a look for this question, and then we will proceed for the next one. See, this is yield strength. This is not sigma y. Okay, so yield strength. So they have mentioned this notation. Usually I used to represent with yield tensile strength. So if you are confusing, so you can just mention yield tensile strength. So this is the strength value. Sigma y, which is nothing but the stress in the y direction. One is the x direction, another is y direction, no? So they have mentioned sigma y, so that's why I have used the same notation. Otherwise, if you see in the previous question also, I used to represent either SYT or sigma YT. Got it, Naveen? So don't confuse with this sigma y and this sigma y. This is yield strength, and this is sigma y is nothing but the stress in the y direction. Okay, so I hope this problem is clear to everyone. Very good question. Okay, so now let's move to the design against the dynamic loading. So we have solved the question based on the static loading. That means you have calculated the factor of safety. So in which the load is not varying in magnitude and direction. Okay, so that is the static loading. Now for dynamic loading, what type of question they are framing? The first one will be there are some important parameter. So let me quickly summarize for you, and then we will move toward the question part. So the first one will be the variable stress, which is denoted with the sigma A. That is nothing but stress amplitude. So sigma max minus sigma min by 2. The second one will be the mean or average stress. Okay, so you will see these kind of notation when I will discuss the question based on the dynamic loading. So sigma max plus sigma min by 2. Okay, so if you see, let us suppose the state of the stress cycle, which is given in this format. This is nothing but sigma max, sigma and time. So stress cycle is given like this. So this is the sigma max, and this will be sigma minimum. Fine. Now, if you want to calculate the stress amplitude, which is nothing but this one. So this is called as a stress amplitude, which is sigma A. Okay. So if you want to calculate the mean stress, this is nothing but mean stress, which is average of the maximum and minimum value. Okay. Now the third one, which is nothing but the range, as its name is indicating, that means you have to calculate the range of the stress, which is sigma max minus sigma minimum. And the fourth one, which is very, very important, which is called as a stress ratio, which is defined as the ratio of minimum divided by maximum stress. Okay, so please make a note. I'm mentioning here, whenever you are solving the question based on either the stress amplitude, mean stress or maximum stress, so please take the sign also for considering this formula. So let us suppose if the minimum stress is given as negative -50 and maximum is 100, so the stress ratio will be minus 0.5. Okay, so you have to consider this maximum and minimum. So I will mention here, consider maximum stress and minimum stress with their sign. Okay, so please make a note of this. You can just have a note of this slide, and then we will move to the question part. Okay, so this is stress amplitude and the mean stress. Again, you will see while solving the problem based on design of dynamic loading, for example, Schroederberg equation and Goodman equation. Now, see this question. For the given fluctuating fatigue load, the value of stress amplitude and the stress ratio you have to calculate. So you already know the relation of stress amplitude and the stress ratio. Okay, so please try to solve. So the first thing is you have to calculate the maximum minimum stress. Option C is correct answer. So sigma max, which is nothing but 250, sigma min, which is nothing but 50. So the stress amplitude you already know, sigma max minus sigma min divided by 2, which is nothing but 250 minus 50 divided by 2, which is nothing but 100 megapascal. So you have to calculate the stress ratio. The stress ratio can be written as sigma min divided by sigma max. What is the minimum stress? Minimum stress is 50, maximum is 250. So can I say 50 divided by 250 is nothing but 0.4, which is nothing but 1 by 5. Okay, so that means which option is correct? Option C. Please make a note of these important what we called as a relation for stress amplitude, mean stress, and the stress ratio, because repeatedly they are asking the question, 1 marks question, based on this important parameter. So this is the GATE 2015. So same type of question they have asked in GATE 2019. For a high cycle fatigue testing, again is subjected to a cyclic loading. Mean stress is given in this, minimum stress is given this, the R ratio. So now they have mentioned clearly the R ratio is minimum stress to maximum stress, which is nothing but stress ratio. Okay, so you have to answer. This is a NET type of question, numerical answer type question. So you have to round off to 1 decimal places. So whenever you are solving question, please see the last statement of the question, in which unit you have to answer and how much you have to round off. It's minus 0.2. Okay. Yes, minus 0.2. So the minimum stress is nothing but minus 70. Many students have taken this as a maximum stress, but they have mentioned it is a mean stress, not a maximum stress. So the mean stress sigma m I am representing. So sigma max plus sigma min divided by 2. So minimum stress which is already given. So from here you will get the value of sigma max. What is the value of sigma max from here? So which is nothing but 350. Now, if you see the stress ratio is sigma min divided by sigma max. Again, please consider the sign also. So, which is nothing but minus 70 divided by 350, which is nothing but minus 1 by 5. So, the correct answer will be minus 0.2. Many student has done the same mistake. Okay, so they have solved the question and then they have marked the answer as a 0.2. But you have to consider the sign also. Okay, so the correct answer is minus of 0.2. Okay, very simple and straightforward. Now, one more question based on the theoretical stress concentration and fatigue stress concentration factor. So, let me first discuss about these two important relation. So, as you know that there will be a KT value which is called as a theoretical stress concentration factor, stress concentration factor. The second one will be the fatigue stress concentration factor. Fatigue stress concentration factor. Okay. So, there is a relation between the notch sensitivity and this theoretical as well as the fatigue. So Kf minus 1 divided by Kt minus 1. So where Q is called as a notch sensitivity, Q is called as a notch sensitivity. Okay, so the stress concentration factor means whenever you will see any kind of geometry variation, okay, so the stress will be concentrated at that particular point. That means there is a rise of the stress. Okay, so this is for theoretical concentration factor. But in actual manner, the component is subjected to a fatigue loading. That means the load is magnitude or either direction is changing. So that's why we have to consider as a fatigue stress concentration factor. So Q basically relates with these two important term, which is Kf and Kt. And based on that, they have framed one question. So which I have shown you, which is nothing but this one. Okay. So the notch sensitivity, which will be expressed as what will be the answer? Yes, option A. Option A is the correct answer, which is Kf minus 1 divided by Kt minus 1. Now, if you see, in case of static loading, the stress concentration factor is not that much serious. Why? Because of the local yielding. So, in case of ductile material, if you will see any kind of stress concentration, so because of the ductile nature or the plastic deformation or the local yielding, the stress value will be redistributed. Okay, but in case of brittle material, that will be very serious. Okay, so I am talking about in static loading, but in dynamic loading, when the load magnitude and direction both are changing, so it will be harmful in case of ductile material as well as brittle material. Okay, so one question they have asked, the stress concentration in static loading is equally serious in both the cases. That means in both the material, more serious in brittle, more serious in ductile, and depend on other factor. So what will be the answer for this question? Yes, option B, because under the static loading, for a ductile material, there is no problem because of the local yielding, the stress value will redistribute it. Okay, whenever there is a higher stress, it will be redistributed because of the plastic deformation. But brittle material, there is no plastic deformation, so that's why it is more serious. But if it is a dynamic loading, it will be serious in both the cases. Either it is a ductile or brittle. Now, let's move to the SN curve. So, there are some of the problems. If you see in the last year also, they have asked this question based on the SN diagram. So, SN diagram means SN diagram means the stress amplitude versus number of cycle. Stress amplitude versus number of cycle curve for mild steel. Okay, so there is a graphical representation of the variable stress and the number of cycle on this log paper, or that means in the log unit. So log of base 10 ultimate tensile strength, and here will be number of cycle. Okay, so there will be a stress variation, the stress amplitude versus number of cycle, you can see. So this point is called as a endurance limit. So log of 10 endurance limit. This point is called as a endurance limit. So endurance limit means that is that value of stress at which the material can withstand for infinite number of cycles. So if you are increasing the number of cycle, okay, without undergoing any fatigue failure, it will resist. That is called as the endurance limit. Now for a mild steel, so this point is nothing but 6. So usually this is nothing but 10 to the power of 6. So we are plotting in base in terms of log. So that means it will become 6. So similarly, this point is 3, and corresponding to this point, there will be strength. What is the strength? Log of 10, 0.9 ultimate tensile strength. This is, you already know, yield tensile strength. So what type of question they are asking? So you already know for the endurance limit, the number of cycle in terms of log, which is nothing but 6, and for 3, this value, ultimate tensile strength, they will give you in the problem. Then they will ask what will be the value of number of cycle or the value of strength. That means one parameter they will give you, the y-axis or either x-axis, the other you have to calculate. So let us suppose they have given this strength value at this point. At this point they have given as log of 10 the strength value. Now they will ask you how many number of cycle it can resist. That means n star value you have to calculate. Okay, so what you will do in these problems, I will discuss some of the problem also. So you know that this is nothing but a similar triangle. So can I take, this is, let us suppose A, this will be C, this is B, E and D. So AC by BC, can I write AC by BC can be written as ED by DB. That means the big triangle and the small triangle. So from AC, what is this AC? AC can I write log of 10, 0.9 SUT minus of this value. Okay, so same relation you will use for solving the problem. 2 marks problem they are asking from this SN diagram. Okay, so you have to only locate those points and then you have to use this equation. So log of 10, 0.9 ultimate tensile strength minus log of 10 endurance limit divided by what is the value of BC? Can I say BC is nothing but 6 minus 3? So 6 minus 3. Similarly, log of 10 S, that means I am talking about this distance, log of 10 S minus log of 10 log of base 10 endurance limit divided by what is this value? 6 minus n star. Okay. Now from here, if they have given the strength value, you can calculate the n star. If they have given the number of cycle, then you can calculate the strength. Okay, so in any way they can ask you. Okay? So under the dynamic loading, sorry, under the static loading, you already know. So I have discussed the Guest-Trescas theory as well as the von Mises theory, which is distortion energy theory. So one question they are framing based on this SN diagram, and the second type of problem they are framing based on the static design. That means the Soderberg equation, which will be used for a ductile material. So as you know that already these parameter, the mean stress divided by the yield tensile strength plus sigma A divided by sigma E, which is endurance limit, is equal to 1 by n. So n is the factor of safety. Variable stress and the mean stress you can calculate if they have given you the maximum minimum. These values they will give in the problem. Okay. So if you want, I will mention yield tensile strength. This is nothing but yield tensile. Okay, so I can represent with sigma YT also, no problem. So sigma E is nothing but endurance limit. Sigma is nothing but endurance limit, and n will be the factor of safety. So now you can design based on the dynamic loading. Okay, so this is under the fatigue load. That means dynamic load. Fatigue loading. Now the second one will be the Goodman equation. Goodman equation of line. Goodman equation of line, which is for the brittle material. Okay, so sometimes they are mentioning as a ductile material and brittle material. So you have to remember the Soderberg is for ductile and Goodman for the brittle. So if you are taking brittle material, the mean stress divided by which strength will come? Ultimate tensile strength, because there is no yield point in case of brittle material, plus sigma A divided by endurance limit is equal to 1. And minimum and sorry, the mean stress and the variable stress, you know how to calculate, which is nothing but sigma max plus sigma minimum by 2 and sigma max minus sigma minimum by 2. Okay. So whereas SUT is nothing but ultimate tensile strength. Ultimate tensile strength. Okay. So they are giving these values. So you have to calculate the factor of safety based on Soderberg and Goodman. Okay, I will discuss some of the problems. You just go through these two important slides. Yeah. One more point I want to mention here. So let us suppose if the strength value is given, based on the strength you have calculated the n star. Okay. So write down a note point. Let us suppose if n star you are getting as a 3. Okay. So that means the number of cycle will be 10 to the power of 3. Why? Because this n star which you are calculating, that is based on log. Okay, but you have to calculate the number of cycle. So that means 10 to the power of whatever the value you will get. So if they are asking the what will be the number of cycle, so first of all, by using this equation you will get the n star value, and then you can take 10 to the power of that value. Okay, because n is basically the number of cycle, and n star, that means this n star is base n. We just make a note of these two equations, and then we will move to the question part. So in GATE 2025 also they have asked 1 marks question based on this Goodman. 2024 they have asked 2 marks question from the SN diagram. I think 22 also they have framed. So this particular topic is very important. So the static loading as well as the dynamic loading. The SN curve for steel become asymptotic nearly at how many number of cycles? 1 marks question they have asked. It's very good. Option C, 10 to the power of 6 number of cycle. Okay. Now, one more question. So read this question. So those who already solve this particular problem, definitely still again it will help you to revise all the concepts. Okay, so try to focus on the concept because in the numerical they are changing the numerical value. If you understood how to approach in the question, that is more than sufficient. A forged steel link with a uniform diameter they have given at the center is subjected to an axial force that varying from 40 to 160. That means magnitude is varying as well as their sign is varying from compression to tension. So can I say, so in this particular question, so the magnitude is varying as well as the, so what is the data given first of all? The diameter is given as 30 mm. Maximum value of force which is given as 160 kilonewton tensile and minimum force, can I say 40 kilonewton compression. The ultimate tensile strength they have given as 420. Endurance limit they have given as 240 megapascal. Now, first of all, you know that for calculating, so what equation you have to use? Soderberg equation. That means Soderberg equation is basically for the ductile material, and you can see here steel is a ductile material. Now, for a Soderberg equation, you already know what is the important parameter you have to calculate. Soderberg means mean strength, yield tensile strength plus variable divided by endurance is equal to 1 by n. So you have to calculate the factor of safety based on this particular criteria. Okay. So you can easily calculate the mean and average value, sorry, the variable value, because maximum force is given, minimum force is given. That means the stress value you can calculate. Yes or no? Because diameter is given, force is given. You can these values known to you. So can I calculate mean as well as variable stress? Yes. The mean is nothing but average of maximum minimum, and the difference of maximum minimum by 2 is variable stress. Now, if you read this question, they have mentioned all these values. That means yield strength is given, ultimate tensile strength is given, and the endurance limit is given. So, just for confuse you, they have mentioned as a ultimate tensile strength also. But you already know for the Soderberg criteria, if you see, the Soderberg criteria is nothing but yield tensile strength is you have to use. For a brittle material, Goodman, you have to use ultimate. Okay, so in every problem, they will give you both the value. But you have to know for Soderberg equation, ductile material means which is the failure one? Yield tensile strength. And that you have to calculate, that you have to consider. Okay. Now, can anyone please tell me what is the maximum and minimum stress? Maximum means F max divided by area, and sigma minimum is F minimum divided by area. So please solve. What is the value of maximum stress and minimum stress? Thank you so much. 226.35. And what about the minimum stress? 56 point. Okay, so once you will check, that value will be minus 56.58. Very good. Now you can see here because it is a compressive. So maximum minimum is given. So I hope you can easily calculate the mean value as well as variable stress, which is nothing but half of the maximum and minimum. So maximum plus minimum by 2, and the variable stress you will get as maximum minus minimum by, what is this value? So mean stress So you will get as 85 megapascal, and the variable stress you will get as 141.5 megapascal. So once you know the mean and variable, this is already given. So can you please tell me what is the factor of safety? What is the factor of safety here? Yes, 84.88, or we can say that 85. What will be the answer for factor of safety? Yes, 1.26. Very good. Okay, so once you will solve mean stress, yield, tensile strength, and endurance, if you will put here. Okay, now if you see here, they have given ultimate tensile strength. So let me correct here. So ultimate tensile strength, what they have given? Ultimate is 600 megapascal. And what about the yield strength? Yield tensile strength is 420. Okay, so you have to use this 420 value here. So once you will solve, you will get the 1.26 is the factor of safety. Everyone is getting the same answer? Yes, 1.26, 1.26, fine. Now, let's try to solve this problem. So in this particular problem, again, the ductile material is there. So minimum and maximum stress they have mentioned. Okay. Now, the endurance limit is given, yield strength is given. So this is also a ductile material. So they have not given you the ultimate tensile strength. So this is a recent GATE 2017 problem only. But if I want to frame this question, I will give you the ultimate also, so that the student will confuse. So there will be a maximum possibility of mistake in this question. What will be the factor of safety? So maximum and minimum they have given. Okay. So you have to calculate first of all mean as well as variable stress. They have not given the minimum, mean, or variable. They have given you the maximum, minimum. So someone is getting factor of safety is 1, 2. Okay. Yes, 2 is the correct answer. So mean stress is maximum plus minimum stress divided by 2, and maximum minus minimum by 2 is the variable stress. So this will be 50. So maximum and minimum both are magnitude same, but the direction is opposite. So this will be 0. So by using the Soderberg equation, so can I say mean stress divided by yield tensile strength plus variable divided by endurance limit is equal to 1 by n. Okay. So this value will be equal to 0 because mean stress is 0. So the factor of safety is endurance limit divided by the sigma A. What is this endurance limit? Endurance limit is given as 100. Variable stress you are getting is 50. So the correct answer is 2. Correct answer is. So this is also a very important problem. Okay. So in this particular problem, you will use the concept of strength of material also. What they have mentioned, a thin spherical pressure vessel. I hope you already know in thin spherical pressure vessel, what will be the value of maximum and minimum stress? Yes, PD by 40 and PD by 2T. Very good. So the maximum stress, can I say P max into D divided by 40? Okay, so this is basically spherical stress. Sorry, spherical pressure vessel. So PD by 40 for hoop stress. In case of spherical, in all the direction it will be same only. But in case of cylindrical, the hoop stress is, what is the value of hoop stress? PD by 2T, and the longitudinal stress is PD by 40. Okay, but they are asking for the spherical pressure also. So PD by 40, so that means minimum stress, can I say P minimum into D divided by 40. So P max and P minimum they have mentioned. So the the pressure is varying from 4 to 8. So what will be the P max? That is nothing but 8. Diameter they have mentioned as a 200. Thickness they have mentioned as a 1. So 4 into 1. And similarly, this value is 4 into 200 divided by 4 into 1. That means if this value is nothing but 400, so this value will be 50 into 4, which is 200. Okay, so you have calculated maximum and minimum stress. So now mean stress will be 400 plus 200 divided by 2, which is 300. Variable stress is 400 minus 200 is 200 divided by 2 is 100. So once you know this value, can you please tell me what is the factor of safety? Mean and variable you know. So they have given you the yield and ultimate as well as endurance. So according to Goodman, so what value you will use? You will use yield or ultimate? Ultimate only. So that means ultimate strength is nothing but 800 megapascal, and endurance limit they have given as 400 megapascal. Okay, so from here, can anyone please tell me what is the factor of safety? I hope everyone is solving this problem because I am getting the response from only few students. Option B is the correct answer. Okay, so n value you will get as 1.6. How you will solve? The minimum mean stress divided by ultimate tensile strength, variable divided by endurance strength is equal to 1 by n. Okay, so all these values you have calculated, just put here, you will get the answer as 1.6. This problem is clear to everyone. Fine. So let's see this question. A ductile material having an endurance limit, yield point is given, yield stress. The maximum and minimum stress is given. The fatigue stress concentration factor is 1.32. The available factor of safety you have to calculate. Very, very good question. Okay, so the fatigue stress concentration factor they have given. So maximum minimum stress is given. So first of all, what you will do? So you have to calculate for a ductile material again, which you will use, which equation you will use. So always remember, they will not mention every time the Soderberg or Goodman. So sometimes they will represent a material. So they have mentioned as a ductile. So which equation you will use? Soderberg or Goodman? Yes, Soderberg only. Okay, so you know that Soderberg equation is mean stress divided by yield strength, variable stress divided by the endurance limit, which is corrected because they have given the stress concentration factor, is equal to 1 by n. Now, first of all, what you will do, you will calculate the mean and variable. Maximum and minimum both are given. So please tell me what is this value first. And the yield point or the yield strength is also given as 294. Now, the endurance limit is given as 196, which is sigma A. But they have given the corrected factor also, the stress concentration factor, that is nothing but 1.32. So you will calculate the endurance limit for this actual stress concentration factor, which is nothing but sigma E dash, sigma E divided by this fatigue stress concentration factor 1.32. So this is nothing but 196 divided by 1.32. Okay, so once you will solve, you will get the value of sigma E dash, and then you can solve this problem. So once you got the answer, you let me know. So anyone please tell me why we have divided this KF? So one of the student got option B. What about the others? Now you know that there will be a component. Yes, corrected endurance limit only. Very good. So you have a, let us suppose you have a specimen like this, okay, which is the actual specimen in which there is no notch. Okay, so this is basically the actual specimen, or we can say that, sorry, the standard specimen. But because of the notch, or we can say that because of the any kind of defect and all, you have to consider the fatigue stress concentration factor. Okay, so that means actual strength is this 196, but if the fatigue stress concentration factor is given, that means if there will be some kind of notches. So in that particular case, the endurance limit will be lesser than the standard specimen. So if you divide this, this will always comes lesser than the 196. Okay, yes, 1.5 is the correct answer. So mean stress, can you please tell me what is the mean stress? How much mean and variable? Okay, so the mean stress you are getting as a 98 megapascal, and the variable stress is 49 megapascal. So now you have to calculate the endurance limit. So mean is 98 divided by yield value is 294 plus 49 divided by what is this value? Corrected endurance limit value 148.48. Very good. Now 148.48, once you will solve, you will get as 1.508. Very nice. Many of you got the correct answer. Is this problem is clear? Everyone? Very good. This is the energy which I want from your side. Okay, so the correct answer for this question is 1.508, which is approximately 1.5. Fine. So let's move to the next question. Now see, this is the GATE 2025 2 marks question. Okay, so I would suggest you please read the question carefully and then try to solve. The recent GATE question, last year only they have asked. So first of all, whenever you are reading the question, so first point is you have to calculate the, what you have to calculate, the maximum value of stress, okay, so that it will not fail. But before that, you have to check which theory you will use or which equation you will use, Soderberg or Goodman. Okay, so how you will identify based on the material. So can anyone please tell me which equation you will use? Okay, so they have mentioned also. So they have clearly mentioned as per the Soderberg, and it is a steel which is a ductile material. So Soderberg equation you will use. Okay, so please try to Everyone got the answer? So what is the question? The endurance limit of specific grade of steel is same as the yield strength. Okay, that means the endurance limit. Let me take this here. The endurance limit is given as yield strength. Fine. The ultimate strength is twice of the yield strength. Okay, so the ultimate strength is twice of the yield strength. So can I say it will be equal to twice of the endurance strength only? Okay. Twice of the endurance strength only. Now, according to the Soderbergh equation, you know that yes, option B, many of you got the correct answer. So sigma m divided by yield tensile strength, sigma variable divided by endurance strength is equal to 1 by factor of safety. Okay. Now, the mean stress plus variable stress. So they have given the factor of safety is 2. So can I say this value is 1 by 2? Endurance limit is sigma e. Now sigma yt and sigma e they have given equal. So sigma m plus sigma a you are getting as sigma e by 2. Sigma e by 2. Now anyone can you please tell me what is this value? Mean stress you already know sigma max plus sigma minimum by 2. What about this variable? Sigma max minus sigma minimum by 2. If you are adding these, so this will be cancel out. So sigma max plus sigma max divided by 2, which is nothing but sigma max only. That means the maximum applied stress is equal to sigma E by 2. Now, if you see, this question was asked in GATE 2025 2 marks question. Very simple question. That means half of the endurance limit. So the option B is the correct answer. How many of you got the option B? Okay. So half of the endurance limit. That means option B is the correct answer. Very good. Now, this is the question was asked in GATE 2021. So, based on the ascent diagram, so what is the question? The figure shows the relationship between the fatigue strength and fatigue life of a material. Okay, so they have clearly mentioned base, or we can say that in terms of log only. The fatigue strength of material for a life of cycle 10 to the power of 3 only. That means you already know this point is, let us suppose 10 to the power of 3. So that means this is 3. So what is this value? They have mentioned 450. That is strength. Fine. Now, while its fatigue strength of for a life of 10 to the power of 6, which is 150, so that means this is 7, this will be 6 only. Corresponding to this, what is this value? That is nothing but 150 megapascal. So log of 10, 450. Okay. Now for 3, you already know this is already given as a strength value. So if this is 450, can I say the strength value also you known to? Now what is the question? Log of 10. So I'm just representing, let us suppose this is S only. Life of cylindrical shaft made of these materials subjected to a alternating stress of 200 megapascal. So what you have to calculate? You have to calculate the life when they have given this particular stress. Okay, so they have mentioned as a 200 stress. That means this value is given log of. So x-axis will become, let us suppose, if I'm keeping as a n star, log of what is this value? This value is 200 megapascal. So that means again you will use that particular equation. So from there you will get the n star value, and then once you will take 10 to the power of n star, that will be the final answer. Okay, so try to attempt. Otherwise, very good, Shubham. 163840 is the correct answer. Okay. Again, you have to consider this particular triangle, the outer one and the inner one, which is nothing but, can I say, the log of 10 is 200 minus log of base 10, 450 divided by log of base 10, which is nothing but 150. Yes, it is given as 150 minus log of base 10, which is 450. Now, either you can consider this is basically n star, or if you want, you can write in the base of log also. Okay, then from here again you will get the same value. Okay, so either you can represent n star, because if you are representing log base, so you can also write this one. Let us suppose this is log of base 10 n. So from here, this is nothing but log of 10 n minus log of 10 base 10 and 10 to the power of 3, which is nothing but 3 only. So I will write simply as a 3. What about this? This is 6 minus 3. So same thing we have done. Okay, so once you will calculate, you will get this log of base 10 n is equal to, so these numerical value you can easily calculate. So from here you will get this value. So anyone, can you please tell me what is this value you are getting? Yes, very good, 5.21. Okay, so from here, once you will take 10 to the power of 5.21, so you will get as 163840. Okay, 163840. So what will be the correct answer? So you have to answer round off to the integer. So this is the final answer. And if you see for this particular question, they have given you a very wide range because there may be possibility you will do some kind of because you are taking 10 to the power of 5.21. Okay, so if you will round off to the second decimal places, that value will differ. Okay, that's why they have given the range is nothing but 152,000 to 165,000. So like that, they have given this unit. So whatever the answer you will keep, that will be considered as a correct one. Okay. So I hope you understood. So what you will do, every time you will construct the two similar triangle and you will try to solve. Okay. This is the GATE 2021 problem. Now, one more problem. If you see, now in this particular problem, they have given the this point stress, which is 10 to the power of 3. So let me rewrite again. You are not able to see, this is 10 to the power of 3, this is 10 to the power of 6. Okay, and this is nothing but the endurance strength, and this strength which is given as 0.8 ultimate tensile. Okay, so whatever the value they are giving, so you have to consider that value. They can give you 0.6, they can give you 0.9 also. Okay, if they have not mentioned, you can consider ultimate strength only. So a machine element having a ultimate strength 600 Newton per millimeter square, the endurance limit is given, the fatigue curve for the element which is plotted on the log scale. Okay, if the element is to be designed for a finite life of how many number of cycle? Can anyone please tell me? 10 to the power of 4. So can I say this value is nothing but 10 to the power of 4? Okay, the maximum amplitude you have to calculate for a completely reversed operating stress. That means you have to calculate the stress value corresponding to this number of cycle. Okay, so this value you already know. This coordinate is nothing but 3. So if I want to write down the coordinate for this point, so can I say this is nothing but 3 comma 0.8 into ultimate strength. What about this 6 comma endurance strength? And what about this? This is nothing but 4 comma, let us suppose, so this will be in terms of log only, log of base 10 0.8 ultimate strength. Similarly, this one will be log base 10 endurance strength. The 4 log of base 10, let us suppose the strength is S, which you have to calculate. Okay, so this is also in plot in the base of log only. Okay, so that means log of 10 10 to the power of 3, if you will do, you will get the 3 value, no? So number of cycle they have given, you have to calculate the strength. Can anyone please tell me what answer you are getting? Try to solve. Anyone got the answer? Again, you have to consider the same triangle, outer triangle, the coordinate which you already know. Okay, so you can write log of 10 0.8 ultimate strength minus log of 10 endurance strength divided by what is this coordinate? 6 minus 3. So what I am doing, y2 minus y1. So let us suppose this is x1 y1, x2 y2, x3 y3. So what I have done, y3 minus y1 divided by x3 minus x. Okay, just I am equating the slope only. So this is 6 minus 3. So can I say what about this? Log of 10 endurance limit minus log of base 10, the strength value, divided by 6 minus So from here, each and every value which is given, ultimate strength is given, endurance limit is given. So you have to calculate the strength value. How many of you got the answer? Yes, very good. So the strength value once you will solve, you will get as 386.2. Okay, so the unit is Newton per millimeter square means megapascal. So in every problem, if you are seeing, you are just equating the slope. So the slope of this bigger triangle is equal to smaller triangle. Okay. Now let's move to the next domain. So if any question is coming based on these two, the static and dynamic loading, I hope you will able to solve it. So the next one will be the brakes and clutches. So first of all, I will discuss some of the problems based on the brake. So 2 marks problem, they are framing mostly from the shoe brake or the band brake. If you see the 23 paper, 24 paper, as well as 21 paper, so they have asked 2 marks question from this particular topic. Okay, so very important and very simple. The only thing is you have to calculate the, you have to find the direction of friction force. So if you are able to find the direction of friction force, you can solve any problem related to brake. Now see, this is the question. Let me discuss one question. A block brake shown below has a face width is given and a mean coefficient of friction. Okay, so everyone please focus on the screen. So the coefficient of friction which is given as 0.25. The actuating force, that means the force which is acting at this end of this lever, we can say, which is nothing but 400 Newton. So they have given all these dimension. So this is your shoe brake. So initially these shoe as well as this drum is not in contact. Once you have applied the force, so it is coming in contact. That means the rotation of this drum is stopped. Okay, and that is the function of brake only. Now what you will do, first of all, you will draw the free body diagram of both the drum as well as the shoe. So once you understood how to draw the free body diagram, your problem is very simple. Now see, let me first write what is the data given. So the load value which is given as 400 Newton. What is the drum? This is diameter. So can I say the radius value is 150 millimeter? Okay. Now if you consider this is a drum which is rotating with this direction and nothing but the clockwise direction. So I will consider this is a drum which is rotating in the clockwise direction. So can anyone please tell me what are the forces first of all it will act over this drum, because it is making a contact with the shoe, okay, at this point. So what are the force will act? Yes, friction force as well as normal force. So the normal force means it is making a contact with this shoe and drum. So can I say whatever the normal force which is exerted by the shoe over this drum, so same normal reaction will act over the shoe. So can I say the normal reaction is this one? Okay, so please focus on this, because if you identify, if you are able to identify the direction of friction force, you can solve any problem related to brakes. Because if you have taken the wrong direction of friction, then definitely you will get the wrong answer. Okay, so the normal reaction I think you will easily locate. So as you know that this drum is rotating clockwise. So can I say this point has a tendency to move in the forward? So where the friction force will act? Where the friction? So in case of drum, anyone can you please tell me in which direction the friction force will act? It is acting on right side or left side? So I'm talking about only the drum. So in which direction friction force will act on this drum? Because once you will able to identify the direction of friction force in drum, so same will be on the shoe in the opposite direction. Very good. On the left side only, because this point has a tendency to move in the forward, then definitely the friction force will act in the backward direction, which is nothing but this one. So let us suppose the friction force is nothing but Fr, which you already know, which is equal to mu into normal reaction. So if this is normal reaction, mu into R, mu which is given in the question itself. Fine. This is the free body diagram of this body. Now what we will do, we will draw the free body diagram again. So free body diagram of lever along with the shoe. Now this is your lever in which the force which is acting, whose magnitude is 400 Newton. Okay, so this is your shoe having a hinge joint, or we can say that the pivot point is nothing but at, let us suppose this is O, which is coinciding with this one. Now if this point has a friction in this way, so what will be the friction force on the shoe? What will be the friction force? It will be towards right or left? In the direction of friction force on the shoe. Yes, right side only, just apply the Newton's third law. So this is nothing but Fr, which is mu into R. Now, if this is the R, can I say this will be, again, this will be the R only, the normal reaction? Fine. Now, what you will do in this particular problem, now you will take the moment about O point. So summation of moment about O point is equal to 0. So first of all, you have drawn the free body diagram of this. Because of this rotation, because if I will change the rotation of this drum, the friction force will act in this direction. Because this point has a tendency to move in this way, friction force acting in this direction. Now in this particular shoe, the friction force will be in this way. Okay. So if the friction force direction is changing, moment value will change. In this particular case, this application of this friction force is passing through this the pivot point only. That means this friction force will not create any kind of movement. So there is no problem. Okay. But if this hinge joint will be at the bottom, or we can say that the above from this axis, then the friction force will create a different movement. Okay. So now if I will take the moment about O is equal to 0, so R into 200, that means this distance which is given as 200. What about this value? This value which is given as 400. So R into 200, 400 into 600. So from here you will get the R value, which is nothing but 1200 Newton. Okay. Now what you have to calculate? The braking torque. So what is the braking torque? The friction force into perpendicular distance. Perpendicular distance is nothing but this one only. Small r. Small r is the radius of this drum. The radius diameter which is given as 300. So radius will be 150. Now the braking torque, can I say the friction force mu into r into small r, which is nothing but 0.25 1200 into small r is, which is nothing but 150. So can I say this is nothing but 0.15 meter? Okay, because you have to answer in Newton meter. So can you please tell me what is this value? Yes, 45 Newton meter, and this will be the right answer. 45 Newton meter. Okay, that means option C. So in this particular problem, if you see, the hinge joint is basically coinciding with the direction of friction force. That means coinciding with the frictional force value. But if this point is above and below, then the friction force will also create a moment. Okay, so why we have not taken the friction force moment? Because if you take this friction force is passing through here, so there is no perpendicular distance. Okay, now if you see the next question, so in this particular problem, the friction force will also play a important role. Okay, read this question. So again, what you have to do, you have to draw the free body diagram of drum. So you apply the friction force and normal reaction and take the moment about the hinge joint. So in this particular case, the hinge joint will be at this point. Let us suppose O. Take the moment, you will get the answer. So first you tell me, if the drum is rotating clockwise in this case, what will be the friction force direction over the drum only? Okay, I'm talking about drum. Very good. Left side. Okay, so please focus on this important part, that is the direction of friction force, because the remaining analysis is very simple. You have to take the moment. Okay, so whatever the forces which will create the moment about the hinge joint you take, you will get the answer. But this direction of friction force, you have to be careful. Okay, so if this drum is rotating clockwise, so let me take new slide. So I have mentioned here. So you can see here, if the drum is rotating clockwise, so can I say, if I want to draw the free body diagram of this drum, so this is the normal reaction R, friction force is mu into R, fine. If I will apply the same friction force over this lever as well as the shoe, so this is your shoe, the force which is acting as 100, which is nothing but this F value, which they have mentioned 100 Newton. Okay, the coefficient of friction they have given as 0.3. Now again you have to calculate the braking torque. So for calculating the braking torque, you need the friction force value. For calculating the friction force, you have to identify in which direction the friction force is acting. Okay, now see, if this friction force in left side, so can I say this will be right side? So mu into R, here will be normal reaction R. What is the distance? This distance they have mentioned as, yeah, this is 200, this is 300, so this distance will be 100. This will be 100 mm, because they have mentioned all dimensions are in mm. Fine. Now, at this point, height which is given as 300 mm, 300 mm. Okay. Now, what about this distance? They have already mentioned it is a 200. Now, in this case, if you see, the friction force will also create a moment. Okay. So, this distance which is mentioned from the this axis only, 300 mm. So, what you will do now, you will take the moment about O point. So, let us suppose the O point is here. So, what are the forces which will create the moment in this case? You just tell me what will be the force, what are the forces in this diagram which will create the moment about O point. Yes, the load, which is the external, the normal force, and the friction force. That means summation of moment about O is equal to 0. If you consider, one will be 100 into this 300. So now if I am taking counterclockwise is positive, so the clockwise value will be negative. Okay, so you can consider clockwise negative, counterclockwise positive, or vice versa. But if you are taking one as a positive, so now what I am doing, counterclockwise I am taking as a positive, and clockwise I am taking as a negative. Fine. So 100 into 300, 100 into 300 plus mu r into 300 is equal to, or I can write as a minus of r into, because this normal reaction will create the moment in the clockwise. So clockwise I am taking as a negative. So minus of r into What is this distance? Yes, they have mentioned this hinge distance is nothing but, you can see here, 200. So r into 200. So from here you will get the value of r. Can anyone please tell me what is this normal reaction you are getting? What is the value of normal reaction here? So mu value which is already given. Yes, very good. 272. Okay, not mm. It should be in Newton, because this is r is nothing but the force only, no? Normal reaction. So 272.7 Newton around you will get. That is nothing but the normal reaction. So if you want to calculate the braking torque, what is the value of braking torque? Mu into r into small r. So mu value which is already given, you can see here 0.3. So mu value which is given as 0.3. So 0.3 into 272.7 into the radius. What is the radius? Radius is given as 100. So can I say this is 0.1? Can anyone please tell me what is this braking torque? The magnitude as well as the unit. Okay, because you have to answer in Newton meter. So please focus on this. If I will put Newton millimeter, the answer will change. Most of the student do the mistake here only. How much you are getting? 8.18. Very. So 8.18 Newton meter you will get the answer. Okay. So 8.18 Newton meter is the braking torque. Okay. So some of the problems I have discussed based on the brakes. So there are other important topics, that is the bend brake and all. Okay. So that I will discuss in the next session.